Alright everyone, I wanted to create a video or two, or maybe more if I can get this to work well, to help you guys prepare for our first test on Chapter 2. What I'm going to do, at least initially here, is to go over some of the questions that are in the review section for Chapter 2 of our textbook. The review section starts on page 164 of our textbook, and then it starts with a concept check, has a true-false quiz, and then exercises. And so I'm going to just pick some exercises to talk about to refresh your memory on some things that we've learned in this chapter, and to illustrate some ways in which we could use those concepts to solve some problems. So I wanted to start with problem number 21 from the exercises. You'll have to forgive my writing. I don't use this thing often enough, and my writing might suffer a little bit. And the problem says if we have the quantity 2x minus 1 less than or equal to f of x, which is less than or equal to x squared, on the interval from 0 to 3, they want us to find the limit as x approaches 0, as x approaches 1 of f of x. So this is all we have. We just have that initial condition here that relates the two quantities x and or f of x to the quantity x squared and 2x minus 1. Now hopefully this reminds you of one of the theorems, one of the named theorems we have in this section. Hopefully it reminds you of the squeeze theorem. Okay. What we have is we have f of x trapped always between the quantity 2x minus 1 and the quantity x squared on this interval. And notice that as we're taking the limit as x approaches 1, and 1 is in this interval. So this is just an application of the squeeze theorem. And so to use the squeeze theorem, we need to have the inequality relationship that we have, that always has to be true. And once we have that inequality relationship true, the other condition of the squeeze theorem was that the limits of the bounding functions were equal. Okay, so I need the limit of 2x minus 1 equal to the limit of x squared as x approaches 1. And if those two bounding functions have the same limit as x approaches 1, then by the squeeze theorem, f of x will have the same limit. So let's see if we can just demonstrate that really quickly. So the limit as x approaches 1 of the quantity 2x minus 1, and since 2x minus 1 is just a polynomial, we can use direct substitution to evaluate this, and if I plug 1 directly in here for x, I'll have 2 minus 1, which is 1. So that was easy enough. And you guys probably already see the result of the last part. The limit as x approaches 1 of x squared, again, just dealing with a polynomial here, and so direct substitution will get us 1 as well. Now since those two limits are the same, by the squeeze theorem, we would have the limit of f of x also equal to 1. And forgive the slow writing here. I'll hopefully get faster as I practice this. Squeeze theorem. Yes, I got to use a cursive L and make it look terrible, but that's alright. Limit of as x approaches 1 of f of x is equal to 1. So it's a pretty simple and straightforward problem. I'm going to stop this recording here, and I'll make several other recordings. Just have that one solution for now, and we'll see what happens.